Hi friends, if you are ever wondered how real-world Java concepts like encapsulation actually work in a microservices project, you are in the right place. In this video, you will see how we build a customer entity class using encapsulation with private fields, headers and setters, just like it's done in the production level apps. And this is just a glimpse to drive depot and master Java, Spring Boot, REST APIs, and real-time microservices. Check out my full Udemy course with a lifetime access. The link is in the description. Enroll now and start building real Java projects today. Let's move on to this video. Let's walk through the concept of encapsulation using our bank customer management system. Specifically, the customer microservice built with Spring Boot. First, let's learn what is encapsulation. Encapsulation means hiding the internal data of a class and exposing only the required methods to interact with that data. It ensures that data cannot be accessed or modified directly. Instead, it can only be accessed or updated using getter and setter methods. Why is it important? Data protection. For the data protection, it prevents accidental or unauthorized changes to your class fields. For the modularity, it groups data and behavior logically, making the code cleaner and easier to maintain. Let's see this in action with a real example. We will create an entity class for our customer table. First, let me create a package for that entity, and then inside that package, let me create entity class. So I'm giving the name like customer. So if it is an entity class, I have to mention it using the entity annotation. So let me add that annotation. So this tells Spring and JPA that this class represents a database entity. In other words, this class maps to a table in database. So we are having the customer table in MySQL, right? So that is related to this entity. If you are doing any changes in this entity, it gets reflected to the MySQL table. That's why we have already added that property in our application properties itself. DDL update. Then let's add the table name here. So for that, you have to mention the annotation table and import that Jakarta persistence table. Inside that, you can mention the table name using name property and then give the table name. Then let's give the column names. First, we are going to give the customer ID. This is the primary key in our table. So let's mention it's a ID. And then it should be auto increment, right? So we have to mention generated value and then bracket, you have to mention the strategy. And then generation type, you have to call the generation type enum and mention its identity. So then it will, while inserting this record, it will automatically increment the value. And then this is the column for the table, right? So you have to mention the column annotation. That's it. Let's add the remaining columns. Customer name, private and string and name. And also mention, this is also column, right? I'm mentioning that annotation. And then email ID. So private, string, email, and then address. Private, string, address. Then password. So make sure you have to add the column annotation for the each and every columns. If you need to mention the particular column name, means you can add it here, name equal to password. Otherwise, it will use the same field name as a column name. Then, now, as per the encapsulation concept, we have added the private fields. Then, let's add the getter and setter methods for each and every field. For that method should be public. Then only can able to access via other classes. So, public long get customer ID. It should return the customer ID, right? So if I'm getting something, I need to return something. So that's why I'm returning customer ID. Like that, you have to add it for remaining fields. Then I'm adding for name. It's returning name. Then for address, email. Then for address, then for password. Then let's add the setter methods. So setter methods, we only going to set the value, so there is no need for the return type. So I'm using void as a return type here, and void set customer ID of the value is passing, right? So customer ID, and then I'm assigning this customer ID to the passing value. Like that, let me create it for name. Like that, let me create it for email. And address. Then password. Okay, now we have added all the getter and setter methods. Here, let's add the condition itself, because during the encapsulation concept, if we can't able to directly edit this private fields, we can able to get and set using this public methods. As well, we can check the condition before setting the values as well. So, for example, for email ID, it should be it should not be null, or some formats I need to check it before set the values. For that, I'm checking that email is null or not. If it's not equal to null, I can able to set that value to my table. Also, it should be included the at in mail ID. So that's why I'm checking email dot contains at. So the both condition gets satisfied, I can able to assign this value. Otherwise, I can throw the exception. Throw illegal argument exception. And you can give the message, so invalid email format. Now we have fully implemented, but if we need to add the values, we can add the all arguments constructor here. So for that, I'm using public and the method that this class name, I have to mention it. Both return type and class name method is same, and then you have to pass the all the way values here. So customer ID, and then string name, and then email, and then address, and then password. This is where during the object creation we can pass that value and assign it here. So that's why we are passing it. So customer ID equal to customer ID, then name equal to name, and email equal to email, and then this dot address equal to address, then password. This dot password equal to password. That's it. We have added all argument constructor as well. And then here I had to add one more braces. That's why it's showing error. Okay. Now we have created the entity with this table name, everything. Then let's go to the MySQL Workbench. Actually, in the previous section, we have created the table using the SQL query, right? In MySQL Workbench itself, we have created it. So let's check on that. So this is the table. Now we are going to create using the Spring Boot application itself. So I'm deleting this table. Using the query drop table and table name. So let me refresh it. Here that table is not available. Let me use the same query. Select to check the table is available or not. Here we are getting the error like that table does not exist. Okay. Now let's go to the IntelliJ IDE. Let's start our Spring Boot main application. Started our customer service application. Okay, now let's check it on MySQL Workbench. Is it that table is created or not? Here you can able to see the table customer. Let me check it using the query. Here, what are the column we have given? Customer ID, address, email, and name, and password. Everything is created. That's it, friends. In this section, we have learned about the how to create entity, and we understand about the encapsulation, how related with our entity concept, and how can we create the table in Spring Boot itself used with the help of Hibernate and JPA. Drop a Java in the comments if you are excited to start, and let me know what Java topics you want me to cover next. Don't forget to like, share, and subscribe if this helped you, and tag your friends who is preparing for Java interviews. Thanks for watching.